Assalamu alaikum.
Walaikum assalam.
Walaikum assalam.
Walaikum assalam.
People are joining, and I am in process of admitting them. And I hope you can see my screen.
Allahu Akbar.
ये अल्लाह वाला कौन है? प्रॉब्लम है आपको? बिस्मिल्लाहिर्रहमानिर्रहीम शुरू करते हैं. Gentlemen and lady, you can see on my screen there is a house, a symbolic house, and there is a sunshine above the house. House has walls, house has roof, house has a chimney, and house has inside rooms, kitchen, person is standing in the kitchen cooking something, and there is a door and window with glass. So this all represents very important, it's a very important thing that how we understand cooling load calculation. Cooling load calculation means cooling load calculation means you have to estimate how much heat is transferred from outside to inside. and how much heat is generated within. So as you can see in this diagram, in this house picture, house diagram, heat, sunlight can pass directly through the window. So this is called solar heat transfer. Sunlight is falling directly on the roof and walls. This is sunlit wall and sunlit roof. So sunlight will be absorbed by the surface of the roof and wall, and it will get heated up. Its surface temperature will increase, and there will be temperature difference between outside surface and inside surface of the building structure, and this will cause heat transfer. Q is equal to U and delta T. This is called transfer load. Heat transfer directly from the transparent walls like window glass is called as solar load, and there is inside source of heat, and that is the occupants, person itself, and other activities he is doing inside. There may be lights, there may be fans working, there may be motors working, there may be there may be some equipment working like computers, projectors, and things like that. So this is called what is created inside the room. That is because of people, because of lights, because of equipment, is called internal load. So from here we define 4 categories of cooling load. So AC equipment, the duty of AC equipment is to remove these 4 types of loads, and duty of AC engineer is to know how to estimate, how to calculate, what is the size of calculating this heat transfer. Let me go to waiting room, admitting all. So first category is internal loads. Internal loads means latent and sensible load of occupants. Occupants may, because of temperature difference, load is heat transfer is called as sensible load. And ventilation requirement. If there is a human or animal living inside, it needs oxygen. Without oxygen, inside air is not healthy, and person may get ill. It may get infected with virus. It may get disease like tuberculosis, things like that. Air inside is always polluted without outside air, ventilation air. Outdoor air, how much should be taken out? What is the effect of this outdoor air on the cooling load? This will be discussed, and engineers should know how to calculate this. Now, lighting. Everywhere inside inside premises we need lighting, because these days natural lighting is very rare to come inside huge buildings, multi-story buildings, office buildings. So in small houses it may be not required in the daytime, but in the night again it is required. So lighting, here it is mentioned 2 types: fluorescent lamps and incandescent lamps. Incandescent lamps are now obsolete. It is a filament type lamps. They consume a lot of energy, so they are obsolete, and their production has been banned, because fluorescent lamps and miniature fluorescent lamp, which we call energy saver, is most popular these days. So they consume less energy, and nonetheless, lighting load constitutes a considerable part of cooling load. We should know how to calculate this. Now, there may be fans working inside, and fans have motors. So these motors consume electricity. This electricity is come inside the room and emitted inside the room as a heat energy, and that estimation is to be done. Now, kitchen equipment, there are ovens, there are stoves, there are microwaves, there are just gas ovens. So these emit heat. Food emit heat, hot food, heat and water vapor. So engineers should be capable of calculating all these internal loads, and this is one category of the cooling load. Second category of cooling load is transmission loads. Transmission means due to heat transfer due to temperature difference. If you have a wall, you have a partition, you have a roof with construction material, inside temperature is different from outside temperature. Outside temperature is hotter than inside temperature in summer cooling. So what happens? Heat transfers from outside surface to the inside surface. So this heat transfer formula is Q is equal to U multiplied by area of the surface multiplied by temperature difference across the surface. So what is U is called overall heat transfer coefficient, and you have already learned in chapter 2 how to calculate this. Thermal principles. This was taught, and in heat transfer, heat mass transfer course, it is taught. That is why it is prerequisite of this subject. Refrigeration air conditioning subject prerequisite is heat mass transfer also. Thermodynamics and heat mass transfer and fluid mechanics. These three subject fundamentals are used for calculation. Now, this is called transmission load because of temperature difference. Now, what is solar loads? I have explained heat gain through the transparent walls only, glass. And it may be heat transfer through opaque wall. What is opaque wall? Where there is no glass, there is cement, there is concrete, there is wood, there is any other material. So that through which we cannot see. It's called opaque wall and roof. So here temperature, here this is heat transfer takes place in opaque wall through heat transfer because of temperature difference. But the difference between sunlit and non-sunlit wall is sunlit walls are hotter. So outer surface of the sunlit wall is much higher than the wall in the shade. So that's why we take into consideration solar effect on the outside wall temperature, and that is why we call it solar. So I am admitting people, they are habitual of coming late. Just like in the college, they are coming late while sitting at home. They're sitting at home and they do not always prepare. I request humbly to everybody, always join the meeting 10 to 15 minutes before the actual time. Actual time is 9:40, you must join 9:30 or 9:25. So to avoid this delay. So now instructor consumes a lot of time, distracted from the lecture, to get them admitted on Zoom software. Now, this was third category, solar load. Solar load may be direct because of sun, direct heat can, because sun rays can pass through the transparent wall like glass, but opaque wall where sunlight cannot pass directly through the wall, but it heats up the outer surface. That is also solar load. Now, engineers will learn. So a lot of data is required for this. Actual experimental, actual observed data or calculated data is required to calculate this solar heat transfer. So we will tell you which sort of tables are necessary. These tables are given inside the chapter 4 of refrigeration conditioning book, and that is I have separated, got it copied, and I will send you as reference material. What you have to do is get printed those tables properly. These are important property tables. Without this, you cannot do your calculation, you cannot solve your problems. Now, ventilation loads. Ventilation, as I've told, for health purpose, for removing indoor air pollutants, for better quality of indoor air and better environment of indoor air, fresh outdoor air is a must. Maybe it a winter, severe cold, maybe it a summer, very hot weather like these days. So you need outdoor air. So outdoor air is a penalty. It is requirement, basic human requirement for life, but it is penalty for on the refrigeration equipment, on the air conditioning equipment. So if it is hot, you are bringing hot air and mixing it with the room cold air. So this will cause cooling load. So you need extra calculation for this. Similarly, in winter, if outdoor air is very cold, negative temperature, below freezing point. So this cold air has to be brought inside in any case. And after that, should be, before entering into room, it should be heated. So heating load is also contributed because of this. So far as solar load, category 3 solar loads are concerned, we need this information about the location. It depends on location and about, it depends on the month and date, and depends on the time of the day, how to calculate this. You will see later we will calculate examples. Now, you should know the location. Location is defined. by latitude and longitude of the location where you are. For example, here 4 cities of Pakistan let long is given. So knowing this let long, you can go to handbook, air conditioning refrigeration handbook, ASHRAE handbook, or any other handbook to find out what is the design outdoor temperature in a particular month, say August or June or July, and what should be the outdoor temperature taken for calculation purposes. This is called design outdoor temperature. For design outdoor temperature, you need location, and for location, through the location, you will go to the ASHRAE handbook or any other handbook to find out solar values of outdoor temperature at that particular direction. Particular location and orientation of the building. It depends on orientation of building, location, as well as time. So now I'll tell you in general, there are 2 types of air conditioning HVAC load calculation. This is called as design. So there are 2 design procedure, design approaches. One is called active design, other is called passive design. First I'll discuss I've already discussed what is active design, 4 categories of load calculation. This is active design by calculation applying fundamentals of heat and mass transfer. And other method is passive design. When you design a building as an engineer, as a civil engineer, as an architect, that should be designed. Be it owner, be it designer, be it engineer, be it a contractor, be it a consultant, he must take into consideration these aspects. So building should be designed energy saving. Or this is called green building. There are standards leader in energy efficient design, LEED. LEED. There's an international organization which teaches, which trains people, which creates standards for everything which should be green. So green means not affecting the environment. For future, for present and future, environment should not be affected. So any activity, human construction activity should start considering these aspects, that this building should consume minimum water, minimum energy. So minimum electricity, water, gas, and things like that. So energy saving building should be designed with energy saving considerations. So appropriate material should be selected. Starting from material selection, design starts. Then orientation of the building. Designer and owner should know which direction he should build the building. But direction is important from cooling load point of view. If building is facing most of the time towards south and east in our Pakistan, it will be heated most. So cooling load will be very high. If it is directed towards north, it will have minimum solar effect, and the cooling load will be minimum. Now, shading devices should be used. Shading devices, you can see it may be curtain, it may be curtain on the windows, glass windows, it may be overhang, जिसको छज्जा कहते हैं उर्दू में छज्जा, ताकि शेड उसका शेड पड़े, तो शीशे के ऊपर शेड पड़े, डायरेक्ट सूरज अंदर ना आए. So that is shading device. So another shading device is we stick a special thin film with the dark, which reflects reflective surface, which reflects like mirror outside, sun rays back to the outside, and solar load is reduced. Now glasses may be used tinted, colored glasses, green, blue, things like that are available in the markets. Those should be used. Thermal insulation on the walls and roof. You remember last year we have arranged ASHRAE branch of this class had arranged a very good seminar where diamond jumbo loan product was introduced and highlighted the importance of building insulation. So thermal insulation in walls and roofs should be used in order to reduce the cooling load. Now, special roof tiles. Special roof tiles has been designed which reflect most of the heat back to the air upward, and less heat absorbed by the surface of the roof, and less heat is transmitted into the building. This is very important. These aspects are very important. So these aspects, when building is designed, taking into consideration these aspects, then this is called as passive design. Active design means now building is ready, building is done, and maybe not done, but we have architectural drawings. From there, having proper data, so calculate these four categories: what is internal load, what is transmission load, and what is solar load, what is ventilation load. So this is called active design, and AC engineers' job is to perform this type. So this is how this is how we design HVAC. Now let me open another file. Now we will take one by one these four categories, and let me see first what is on the chat room. Nothing, no problem. I hope everything is going well. Okay. So now this second page shows how, in detail, how to go to internal heat gain. So internal heat gain consists of following items. These are shown on screen. These are shown in the screen, and it is lighting. Lighting emits sensibly, it is a light bulb. And people, which is called occupant, it has two types of loads. One is latent load and other is sensible heat load. So next item is other electrical appliances which operate with electricity. It is computer, it is laptop, it is desktop, it is any other computer, any other gadget like a projector in classroom. And now cooking appliances in residential buildings, we have cooking appliances like in the kitchen. So it may be gas burner, it may be microwave, it may be any other burning device. So latent and sensible heat load is emitted by kitchen utensils when we are cooking, and food also when we are serving in drying room. Now electromechanical equipments are there inside the house, it may be inside the kitchen. So this is ceiling fans, for example, some water pumps, motor is inside, and motor of the fans also. Now, any motor, pump, or fan has electrical motor, and that consumes electricity. Any device which consumes electricity emits equal amount of energy as a heat. So that is taken as sensible heat. So these are major components of first category, that is internal load. And now we will take one by one out of these internal load. First one, let us take lighting load. Lighting load can be estimated in two methods. One method is watts per meter square. Any floor area, you know the floor area of the room. So divide, we usually have thumb rules. We have thumb rules that, for example, 2 watts per foot square. Electrician suggests that 2 watts per foot square. If you don't know, electrical design is not available. Sometimes electrical engineers do not perform calculation. They say, "I'm not ready," so you should not be waiting for him. And just take on floor area basis what is the electrical load. Electrical load for residential building, office building is usually taken 2 watts per foot square of the floor area. Now, actual lighting loads can be calculated if you know number of lights, how many lamps are there, and what is their wattage. Then you can calculate with this formula actual lighting load with this formula. This is Q light is equal to lamp rating in watts multiplied by FU multiplied by FB and multiplied by CLF. What is FU? It is called utilization factor. FB is called ballast factor of fluorescent lamps. And this is also obsolete now. This, when we had long tubes, long big tubes, tube lights. These are called as fluorescent lights, and they had a coil or stability of the current through it, and that is called as ballast. Ballast, choke, we get it, choke and ballast. Now, for design data, okay, we are running out of time. We'll continue, inshallah. Next lecture will be 10:30, 10:35. So please join 10:30. Next lecture, and I will stop this lecture over here. So please, today there will be another lecture at 10:35. So join second meeting, and we will continue this talk. Okay. So next is LS factor. So these are coefficient 1.2 for fluorescent lamp, and utilization factor. This we will discuss in detail. It is called also diversity factor. Diversity factor means not all the bulbs which are installed in the building are used at a time. So we should know what fraction of those bulbs our electrical load is on at a particular time when we are designing. We are calculating calculation load. We have to multiply total installed capacity of the electrical bulbs multiplied by some factor, which is a fraction. CLF is another factor. This is the radiation factor, cooling load factor. It is called CLF. When you start a lamp, it will not immediately emit heat and transfer to the cooling load by equipment. Cooling equipment accepts this after a certain time delay, and this is called as cooling load factor. So I think time is running short, and let us stop this meeting here. So I think still 5 minutes are remaining. So I can continue. Now, estimation formula for occupant heat gain. It depends on number of persons. So number of persons N multiplied by QS of each person. Every person emits a particular amount of sensible heat. For example, a teacher standing in the classroom emits 150 watts. It is equal to 150 watt bulb. A student sitting in the classroom and listening to the lecture, it equal to 100 watt electrical bulb. So this is called sensible load, and multiplied by number of persons multiplied by CLF. Cooling load factor. Again, that person, when did enter into the room, how long he is sitting in the room, it depends on that. And this is reflected by this factor CLF, and this you can find in data tables. Now, other part of this internal human occupant's load is latent load. Every person emits perspiration. Every person respirates. Sans leta. So every respiration emits carbon dioxide plus some moisture from the lungs. So that is called as latent load because of steam coming out of your body in the form of perspiration, pasina, and in the form of respiration, sans. Sans or pasina ki madad se you emit latent heat to the room, and that has to be estimated. And the formula is Q element of each person multiplied by number of persons. It is written here in watts. Now this data is also available in design tables, design handbooks. Now, and your textbook also, and it is included in your reference material. Now, CLF cooling load factor. It is 1 for latent load. Cooling load factor. Latent load is immediately released to the room, immediately goes to the air refrigeration machine. So cooling load factor is 1. But temperature, heat transfer, radiation from the body, conduction, convection, and radiation, it takes time to reach the machine. So that time delay effect is called cooling load factor. For design data, refer table 4.7, 4.8, 4.9 at page 74 of the textbook. These tables are copied by me in PDF format, and I will transfer to you by email. I share with you by email, and that as a reference material, and you should get them printed, ready in hard copy before calculating any design, performing any design calculations. So let me share another one. Here you can see another category. We've got only, I think, 2 minutes remaining, so we may continue. So transfer heat gain. So until now we have discussed internal load because of people, because of lights, because of equipment, electrical equipment, things like that. Now second category is transfer heat gain. It is heat transfer formula is written here. Remember this for our Q is equal to UA delta T. Delta T is TO minus TI, that is T outdoor minus T indoor. And U is overall heat transfer coefficient. And you must know, you have learned this in chapter 2 here, it is repeated, you have learned this in heat mass transfer course. And A is the surface area of heat transfer A. So in SI system, A is in meter square, delta T is in degrees Kelvin, and U is overall heat transfer coefficient. It is in watts per meter square Kelvin. This is the unit, watts per meter square Kelvin, and reciprocal of U is R thermal, total thermal resistance of the wall. So what you do is, knowing the material of the building and structure, and knowing the thickness of the, and knowing the thermal properties of that structure, you can calculate R resistance. And chapter 2, sold example is given there, and you have already done chapter 2 calculations. So here, this example is given, another example is given in chapter 4. This we will do, and here is solution in the form of this table. And what is the thermal resistance of each building? Total thermal resistance is given here. Say 2 point something. I will zoom it a little high for you, so you should be able to see it. Here. So 2.812 meter square Kelvin per watt. Reciprocal of this R thermal is U factor, and its U factor or U values unit will be reciprocal of this unit, that is, it will be watts per meter square Kelvin. Resistance is in meter square Kelvin per watt, and conductance is watts per meter square Kelvin. This is called U value. So here we will stop today's this particular lecture. Next lecture will be after approximately after 20 minutes at after 30 minutes at 10:35, inshallah. Okay then, that is